So something like this, 2 to the power of x equals 8. This isn't built to be particularly difficult. Hopefully you can spot here that 2 to the power of 3 is equal to 8. Or in other words, 2 times 2 times 2. And we could write that. We could write 2 to the power of 3 is equal to 8. Now when it comes to logarithms, there is another way of writing this. Now, just like when we're looking at these powers here, we know that this number here, this 2, is called the base number. And that's going to apply when we look at a logarithm. Now, what we say for a logarithm, and this is going to mean exactly the same thing, it's just a different way of writing it. We're going to say that log with a base of 2, just like here, we've got our base number of 2. What log with a base of 2 gives us the answer 8? So log base 2 of 8. And we might say that equals x or something, or we're trying to find out what that answer is. So what power of 2 gives us the answer 8? And we know that the answer's 3. Okay, we've just worked that out. And that would be the answer there. If we wrote log base 2 of 8, our answer would be 3. So all that this means here is essentially what power of 2, what power of 2 is equal to 8. There we go. And that is really the fundamentals here behind logarithms. And as long as we can understand that concept, we can look at it in all different types of ways. But all we're going to be looking at here is basically what powers of certain numbers equal particular answers, and sort of mixing those and sort of rearranging that in certain ways. Now we could write this as a sort of, not as a formula, but we could write this obviously with letters rather than having the numbers here, and looking at how obviously we rearrange this. So we could say that log base of, and let's just call it a, with this letter b here, is equal to x. And what that means in terms of a power. And that means that, and again, the base of a is our main number here, or in this term, obviously writing a letter at the moment, but a to the power of x equals b. And that there is obviously something pretty key to write down, because that's how we're going to be sort of writing these and writing them in sort of different ways as we move through this video. But obviously, just thinking about this logically, log base 2 just means the number 2 to the power of something gives us this answer here. Okay, so what power of 2 gives us the answer 8? And that power there is 3. So let's think about a different example before we move on. I could say something like this. Obviously, rather than writing it as a power, we could say log, and let's go for base 3 this time. So what power of 3 gives us the answer 9? So we'll go log base 3 of 9 equals x. And I might ask you here to find the value of x. So if we've got this little problem in front of us, we would say, okay, well 3 to the power of something, and we've obviously got the letter x there, is equal to 9. So what power of 3 gives us the answer 9? And hopefully that's nice and easy for you to spot. We know that it's 3 squared that equals 9. So we would say x equals 2. Or we could say, you know, log base 3 of 9 equals 2. But that's really the fundamentals here behind what logs mean and how we're going to use them. Okay, so something a little trickier here. We've got find the value of x such that log base 4 of a 1 over 64 is equal to x. Or in other words, what power of 4 gives us 1 over 64? Well, let's write this out. So we have the base of 4, so 4 is our base number. 4 to the power of something, which is our x this time, is equal to 1 over 64. So we know from the last one, again, obviously depending on how comfortable you are with your negative indices, we know that in order for it to be a 1 over as the answer, it's going to have to be a negative power. So we already know part of the power here. We know it's going to be 4 to the power of minus something. And we need to get to 1 over 64. So what power gets us from 4 to 64? Well, we can work that out just down below. Let's have a look. 4 times 4 is 16. And if we times that by 4 again, isn't the nicest one to do in your head, but 16 times 2 is 32. Double that again, we'll times it by 4, and that gets us to 64. So it's 4 times 4 times 4, or in other words, 4 cubed. So it's going to be 4 to the power of minus 3. So there we go. We know 4 to the power of minus 3 gives us 1 over 64. So we could say log base 4 of 1 over 64 is equal to negative 3, the power there. Or in other words, x equals negative 3. And there we go, there's our final answer. So that's all that this means when we're looking at logs, okay? So it's just about looking at the way that the log is written and reading it just like we recognised before. Log base, and then we have our base number, Then it gives us our answer, 1 over 64 is equal to what power, or in other words, what power of 4 gets us 1 over 64. Okay, so as long as you read it like that and sort of understand the way that that writing translates to that wording, you should be absolutely fine working through some of these problems. Okay, so this question here will show you how obviously we can use logarithms to actually solve some of these indices problems. So we've got here, find, giving your answer 3 significant figures, the value of x for which 5 to the power of something equals 10. Now this is quite nice, and this will show you why logarithms are so useful, because we can actually just type these in straight into the calculator, but obviously it does mean that we have to know how to write this power as a logarithm. Now if we write it out, so we're going to have log, there we go, and then we need to put our base number in. So here we've got our base number of 5, so log base 5, and our answer is 10. So what power of 5 gives us 10? Now you can type this straight into your calculator and we'll be able to get our answer straight away. So if you have a look on your calculator, and everyone has different calculators, so you can need to find your button, but there is going to be a button on your calculator. I'm using a Casio ClassWiz, which again I really recommend, and I'll link that in the description, but just underneath the on button or somewhere on your calculator there's a little button that looks like this, and it normally looks like log, and it has like a little coloured in square and then a little open square. And if you can find that button, you'll be able to do these no problem. So find that button, press that, but get 5 in your little base square and then 10 in your larger open square there, and type that in, and let's have a look. We get the answer, and I get on my calculator 1.4306765558, which again, if we give that to 3 significant figures, chop it after the 3, we get 1.43 as our answer. And there we go, it's as easy as that. And you can even test that out if you want. You can press 5 to the power of and then put the answer in, and you will get the answer 10. Obviously if you don't put the rounded answer in, but you put the original one in. So this question says express log 2 or log base 2 of 4 plus log base 2 of 16 as a single logarithm to base 2. And a lot of these links here come to our basic understanding of our laws of indices. And if I talk about this sort of logically, and it will require you to obviously understand what we went over in part 1, but if we look at log base 2 of 4 and we actually calculate that, and that means what power of 2 gives us the answer 4. And if we write that down, let's go for this here. So for this part here, what power of 2 gives us the answer 4? And hopefully we're happy to know that is a power of 2. So let's just give that the answer, x equals 2, if we obviously incorporate that x into our calculation there. For the second part, we've got log base 2 of 16, and again that means what power of 2 gives us 16. Okay, and that power of 2 that gives us 16 is 4, so x equals 4, or the answer's 4. So really what this question is asking us to do, it's asking us to add these two numbers together. So we have 2 plus 4, and let's keep it all in the same colour there, and we know that the answer for that is 6. 2 plus 4 is 6, but obviously it wants it as a single logarithm to base 2. Now in other words, and there is a little quick trick to this, we don't have to do this for every question, you'll see the little trick here, but in other words it wants us to write which log with a base 2 has an answer that's going to come out as 6. So log base 2 of what number is equal to 6? And we can reverse that, okay? So we can think about this as we did in part 1. We can say, okay, well 2 to the power of 6 is going to equal that number that's going to go with our log there. And all we need to do is actually work that out. So 2 times 2 is 4, times 2 is 8, times 2 again is 16, times 2 again is 32, and then times 2 again is 64. So x there equals 64. Or in other words, if we're going to write this log as a single logarithm to base 2, we would write log base 2 of 64. Okay, now let's think about how this links to what we've learnt already looking at laws of indices. Okay, so if we look at these two numbers that were in our logs, 4 and 16, well there's a link between 4 and 16 and the one that we have now, 64. And that link is essentially, we just have to multiply these numbers together, 4 times 16. And that's going to incorporate our first rule here that we're going to look at with logarithms. Let's just get rid of this little bit on the right here, and let's have a look at what we're talking about. So in other words, if we have log, and let's just put base x, and then a number, so let's have it as a for this one, and we add to that another log, and what is key here is it does have to have the same base, and we'll talk about how that links through to our indices as well, with another number, let's call that b. Our resultant log, okay, the log that we're going to get from that is going to be log with the same base, base x, but it'll be a multiplied by b, or ab. So all we actually have to do when we're adding these logs together, so long as they have the same base, and that's absolutely key, we just multiply together those numbers at the end. And if we think about how that links back to some of the algebra that we've done at GCSE level, if we have something like a squared, and we multiply that by a to the power of 4, multiplication being involved there, we add the powers. And we got a to the power of 2 plus 4, which will give us a to the power of 6. And hopefully you can see, look, those little numbers, 2 and 4, link back to our 2 and 4 here, and our 6 and our 6, and it kind of all links together back from what we've learnt on obviously our laws of indices there. Okay, so that's essentially all we're going to do when we're adding logs together. One thing obviously that's very important here, this is when we have the same base number. Just like when we learnt this with our laws of indices, these powers here with our a's can only add together as long as we have the same base letter there, and in this case that was the base letter a. So a to the power of 2 times a to the power of 4, we can add those powers together, but not if we change that base number. And that rule's going to apply with these logs here, and in both of these we had a log base of 2, so we're able to just multiply those numbers to get our final log. Hopefully nice and simple, and obviously you can obviously think about it logically like I did in this first scenario here and working it out like that, but it's much quicker if we have the same base numbers just to multiply those numbers together at the end. So there we go, there is our first rule. This is your key piece of information to make sure you have written down, and that is what we're going to do for adding logs. Now we're going to have a look at taking away, so let's look at that one now. Okay, so you're going to see a lot of links